Hey, everyone. So, I realize you're all still filtering in. There's a lot of you, and you're, from where I stand, quite up scary high, some of you. I can't really see you because of the lights. That if I do this, it just means that I'm being blinded. Hello at the back. Hello. Wow. I don't know if you guys may not know, you may never have been up here, but this thing is kind of suspended over the actual stadium down below. And when you walk upon it, it kind of bounces under your feet in a way that says to you, do you trust the engineering skills of the guys that put this up? Look at those cables. That's all that's between me and certain death. Yeah, hence the kind of blue M&M story from Van Halen. Okay. I will just, while you're finding your seats, I will do kind of the boring bit where I talk about me. So don't panic. If you're towards the end, there are people on the sides. If you could all shuffle in towards the middle a little bit, that would probably really help, because otherwise the folks on the side are having to climb all the way up to the back. Some of them may be suffering altitude sickness at this point already. Okay, for those of you who don't know while you're sitting down, my name is Ian Cooper. Hopefully, especially those of you packed in the middle, you've come to hear me talk about clean architecture and .NET. If you're in the middle and you're expecting to talk about Ruby or something, I'm sorry, but you may be in trouble now. Okay, this is kind of my bio, and it's really fairly dull. It just says I'm old. But the key point is what I always try and mention is the one on the bottom, right? Which is I would really encourage you not to believe there is any difference between you and me. I am not special. I'm not better than anybody here. I'm just another dev. I just happened to get into standing on this side of the stage because, frankly, when I started doing .NET, no one was talking, and I was running a user group, so I had to get up myself. It is really good for you to do it. It helps you organize your thoughts. It helps you think about material and how you present it to others. It makes you think about how you articulate your opinions. And I would encourage all of you to have a go. Find a local user group. There will be people that want to help you and try and get into sharing your thoughts with people. Okay? Please do try and stand up. You are just as good as me. That's who I work for. You're probably uninterested in who I work for. The only thing to say about it is I work for a software company, not a consultancy. I'm not trying to sell you anything. I have no books. This is an open source project called Brighter that I work on. You'll see some code examples towards the end that use Brighter. It is a Cqrs library, it is a task queue library, and it is a messaging library. It's similar to, say, Mediator and Mass Transit. And we're lucky enough to have 20% time at Huddle, so we can spend quite a bit of time supporting and working on this particular platform. Please do check it out. I do have some stickers in my bag down here. I can put them on the table. If anyone fancies a Brighter sticker for their laptop, they're kind of cool. We couldn't get Scott Hansman to pay us any attention as a project until we had stickers. Once we had stickers, Scott cared about us. So if anyone wants a sticker, come and grab one off me at the end. Okay. What are we going to talk about? So I'll start off by having a sort of bit of a tiny chat about loose coupling and high cohesion, because they're kind of relevant to what we're doing today. Then we'll go back and talk about layers, right? Because layers are really the key to understanding what a clean architecture is. We'll talk about domain models, because some of the interesting bits about clean architectures are how you deal with a domain model, and what lives in entities, what lives in interactors or ports, whatever you're going to call them, depending on your preference. And then we'll talk a little bit about this idea from Bob Martin called the clean architecture explicitly. And then I will probably deal a little bit with this issue of how you implement ports, interactors, whatever you want to call them, because that seems to be the bit that most people struggle with when they're trying to work on this kind of project. And I've got a little example piece of code we'll take through that goes from sort of just a MVC app that's essentially got all the code inlined in the controller, and we'll show you basically putting that in different places to try and improve the design of that application. So the term clean architecture, just to really call it out, was one that came from Bob Martin, and he's got a book called Clean Architecture. The book tends to have a lot of his material about being clean. So Bob has this whole series of books which use the word clean to effectively mean well-engineered, very modifiable code. And the Clean Architecture book takes some of his existing ideas that you all know and love, solid principles, etc., and talks about them in an architectural context. But the core idea of the book, he's also mentioned in various blog posts, is this idea that there is a architectural style, which he calls the clean architecture, which is a very useful approach to a large number of systems, particularly most line of business systems. Now, Bob's pretty clear that that's not his idea. What he's doing when he calls it clean architecture is actually collating a number of ideas that have actually occurred to various people over the history of computing. And some particular call-outs we might want to make at this point who inspired this idea of clean architecture. One of the key ones is Alistair Cockburn with the ports and adapters or hexagonal architecture. Ports and adapters is the technical name. It's often referred to as hexagonal because the diagrams essentially have hexagonal shapes in them. The Jeffrey Palermo, in the .NET space, came up with this idea called the onion architecture. And a long time ago, back in the 90s, Ivor Jacobson came up with this idea called boundaries, controllers, and entities, or BCE. They are all essentially variations of the same thing. They are all rediscoveries of this same ideal architecture. You know, we get this kind of thing that happens in computing, is that we continually reinvent everything. You know, everything was actually invented in Smalltalk back in 1980 or whatever, etc. But the reality is we just keep reinventing the same kind of ideas. And what Bob was calling out is there's this common theme to the set of ideas as to how we would organize our architecture that seems to have evolved quite independently amongst these individual practitioners. But if you look at it, are essentially saying the same thing. And what we'll do in this presentation is we'll wander through a few of those different kind of routes to get there, because actually having a range of them helps us to really understand each one. Because, so for example, look at ports and adapters, one of the questions people often have is, well, what is a port? I get what the adapter is and what the domain is, what is the port? And if we look at other ideas like BCE or just simple service facades or the onion architecture, actually we can get a clearer idea of some of those more confusing pieces. All right. Let me show you, first of all, some code. Where am I? Okay, let me just switch the repo. Okay. So this is a pretty standard .NET Core. Can everyone see that at the back? Do I need to make it a bit bigger? Can I make it bigger? Bigger? Bigger, right. Because you're all the way at the back of this one. Bigger? That's good. Excellent. So this is a really standard .NET Core Web API app, the kind of thing that I'm sure you build, or you've built a version in MVC, Web API for pre-core, or you've used, I don't know, Nancy or OpenRaster. But it's a fairly standardized thing, right? And all we have here is essentially a controller, and we have various methods that receive HTTP requests on here. So we can say, I want to basically get, we can say get by ID, I've got post, and I've essentially got delete. Now, what this application is actually doing, I will show you by looking at some tests. So this application, every speaker needs to have their demo application, and I decided to create the world's most over-engineered Hello World application. Because you have to have a domain simple enough to explain in about 2 minutes, and then really cope later with the fact that simple domains don't help you. So essentially what we can do is we can get a whole list of greetings, we can post a new greeting, Hello World, or you can see Hello Mary or Hello Alice, right? And we can delete greetings. Now, somewhere over here, I can probably spin this up and show that it actually works. Let's have a quick look. I don't want Future Stack. I want this window. This bit is, if you can't read it, is unexciting. I just need to build this piece of software and then run Docker to run it. So if you can't read it, don't panic. There's nothing here that you really want to care about. But when we flick back over here, what you'll see is that all of the code is essentially inlined into the controller. So when I do a get, I'm simply going to get a greeting context. So that's basically an entity framework context. Just standard entity framework boilerplate code with a set of basically my greeting objects. Right. And then I can turn them into an array, and then I turn those arrays into some kind of view model object, my greeting ID result. And then I put out my greetings all result essentially as a return, and good old ASP.NET is going to return that into some nice piece of JSON for me that represents essentially my actual objects. And when I, post down here, ignore these few lines, we'll come back to those a bit later. I'm grabbing a context, I'm creating a new item, I'm saving the item essentially, and then I go and retrieve the item, just put it in the database, and I then return OK and give you the representation item I just retrieved from the database, and let the ASP.NET runtime take care for me of basically turning that object into some lovely JSON that goes on the back end. Okay. And we're running through that reasonably fast because I'm sure that you've all built apps like this many times. Okay. And just so you can see it working, we can run some tests against this file. So I can send a request, and you'll see back it's saying to me, right, well, you've got an empty database, here's 200 OK, and I can stick a request in, so basically it goes away and it says, okay, I'll add that entry into the database, and then I'll query the database with the ID that just got inserted. I'll get the item out, and I'll basically put the JSON back out onto basically the wire for you, and you can see basically I've now got the ID of the item added. So now if I get all the items, you can see that I've got that item, and I can add another one, and you can see that I'm now getting multiple items, right? When we look at this code, obviously, we may wonder if this is good code. Given the complexity of the problem that I'm solving, it's probably absolutely fine. Okay. But if this is actually a genuine business problem, we might begin to wonder whether this is the right way to do it. I've got quite a lot of repetition around this idea of going and grabbing a single item by ID and turning it into a result object, basically, that I then put out on the wire. Right? I do it there and I do it there, and it's a repetition between the same bit of code. It's just doing the same thing. I've got quite a lot of ideas mashed into my controller. Right? Here's my basically abstraction over. Here's my context basically for entity framework. Here's some link statements, talking to the database. Here's this weird bit of code that's basically supposed to be writing out some kind of console application to say I received some data, logging in something in some way. And maybe that's not the best idea. Maybe actually I could think of a different way of structuring my application so that all these different ideas weren't mashed into the controller. And as a thought experiment, the other thing to think is, let's say I built this originally in a different framework, like OpenRaster or Nancy. And then I decided when .NET Core came along, you know what, I'm going to use basically Web API for .NET Core. It'd be quite difficult to transfer that code around, right? Because I have to take all this code out of the controller, I have to figure out basically what goes where, or if I wanted to just use a console application to call this, how would I do that? So how would I swap over the interface given that it's all there? And the other question is, how do I get this under test, right? How do I test that get controller? Well, I could potentially, I may be able to just spin up that controller, but actually it does some weird things with that return OK and task action result, and what am I going to do with those? And maybe I get some test harness that lets me spin up controller instances so that I can actually test my code living in my controllers. But now my tests have taken a dependency on that framework for testing MVC API controllers. And if I wanted to move that code to a console window, how do I know that it works? I've got to repeat the tests now in the console window. I can't extract them away from that testing harness. So maybe there's some kind of better way of doing all this. Okay. All right, so that's just kind of setting the scene for you, and then we'll talk a little bit about this idea. Who's heard of loose coupling and high cohesion as an idea? Okay, most of you, right. So my job title says that I'm a software architect, and a lot of people say, well, what does a software architect do? Isn't that just a highly paid developer? That isn't really true. Software architects actually engage in a particular subsection of software engineering called software architecture. And one of the key responsibilities that software architects have is partitioning. And partitioning really means breaking up the system into pieces. And the reason we want to break the system up into pieces is we want to improve basically the modifiability of the system. We want to make it easy to change our software. It turns out that writing version 1 of the software is usually very easy by comparison to maintaining it. I saw a tweet recently by someone who'd gone to work at Starbucks, and he'd internally heading up their IT function. And he previously worked at a digital agency. And digital agencies, what you tend to do is you support a given advertising campaign. I'm going to produce the site for the Han Solo movie, and I'm going to do all the interaction for customers. And it's ephemeral, it doesn't last very long. Time to market's really important. You produce this software and then it dies. And that was his entire experience. And when he got to Starbucks, he realized, wow, these guys have got a huge problem, that they've got source code that's living for years. Applications that live for years. It costs too much money to rewrite them. And really a lot of the developers here, one of their key focuses is, how do I maintain software? How do I keep that software alive? And one of the things software architecture in theory helps with is, how do I make it easy to maintain software? And partitioning is a key strategy towards doing that. Okay. And a clean architecture, this concept we're trying to talk about, is one where we say, okay, the partitioning will lead to low coupling and high cohesion. What do we mean by those statements? Okay. So coupling is this property of a system that when we make a change over here, that ripples, and we end up basically with all these things over here needing to change as well. Okay. So I change the interface that I'm using by effectively changing the signature of a given method call, and that has an effect that all the callers now need to be modified. So those two things are said to be coupled, because the change here ripples out and affects those things. So we can have this direct dependency style coupling, where one given module, and you can read for that anything class, modules in Python, etc., whatever your particular preference is, has a direct dependency, and it says, if that changes, I will change. But you can also have coupling about knowledge. Okay. So the algorithm for calculating your insurance premium lives in this module. If I cut and paste that and put it in another module, I now have coupling between these two modules via that duplication. So the problem with duplication is really about coupling. Duplication as a problem is a special case of coupling. The reason why some things, even though they are duplication, are not something you need to worry about, like I call string format loads of times on my application. Should I replace every call to string format with another method call that wraps all my calls to string format? Of course not, because that's totals all the way down, right? I then have to replace all the calls to that to something else. So you might say, well, hang on a minute, isn't it duplication? And the answer is, it's not duplication in terms of duplication of knowledge. So you haven't coupled two things. If both of these two modules contain my algorithm for how I calculate an insurance premium, if I change module A and I change the algorithm for how I calculate the insurance premium, if this module doesn't change, then essentially I have a problem that I'm now calculating the insurance premium correctly on both sides. So I'm coupled. Now you may think that's insane, that would never happen. I used to work on a complex risk management platform for mid-tier banks. And we used to calculate a whole range of statistics that traders care about, basically, these Greeks as they're called, right? And we literally had, on different screens, different numbers because different algorithms have been used to calculate those numbers on different parts of the system. And we had a problem of coupling because we had multiple representations of that piece of knowledge. So we can say something is loosely coupled if a change to one item doesn't result in a ripple effect and a change to another item, right? And loose coupling is something that is desirable because it reduces the cost of change. I can just say, hey, this project involves me changing our insurance algorithm. I'm going to go and change these modules, but the rest of the system is fine. There's no impact. All of the teams don't have to worry. Okay. And cohesion is the property that we're subject to the same forces of change in a module. Okay. A module with low cohesion has many reasons to change. Right? If you just basically have one module and everything is in there, right? And it includes essentially I'm building an insurance application. It includes my management of brokers. It includes my claims system for working out when someone claims against their household insurance policy. It includes my actuarial stuff for basically figuring out what life insurance premium to charge you because you smoke. If all of that is in the same module, then I have lots of forces wanting to change it, right? And the problem with that is, as soon as I change a module, really I have to retest that module. That's kind of my testing boundary for kind of QA, and it's also my boundary for continuous integration and rebuilding the software. And why should it be that my management of my relationship with brokers is impacted because you need to change the algorithm deciding on how much your insurance premium should be because you smoke? Okay? So if I have unrelated ideas in the same module and I have different forces of change, we tend to say essentially that a module has low cohesion. Okay? And a module that has low cohesion has too many reasons to change. And that results in basically the code smell we call divergent change. Okay. All right. Let's talk a bit about layering. So this is a classic layering model diagram of a system. Who has built a system with layers? Okay, and everyone in the room, right. And this is a classic 3-layer model. At the top, essentially, I have my presentation logic, my UI. So this essentially is where effectively I have my MVC and a layer, a pattern where effectively I figure out what I'm going to put out my web API, what I'm going to put out basically HTML I'm going to put out via MVC, or maybe I'm actually in a Restclient and I want to talk about basically what happens on my Windows Form WPF page, right? Down below that I have my domain model, right? That is the business logic. That's how I figure out what I'm doing. That's where I calculate your insurance premium. That's where essentially I deal with your claim for your water tank having burst. And down the bottom, I've got the infrastructure layer, quite often referred to as the data layer, but it's essentially where I'm doing things like getting data, talking to a third-party system to look up zip codes or postcodes, etc. Right? And the key idea in this layered architecture is that dependency is always downwards. Okay, so I depend down. And that means I don't end up with these notions of circular dependencies, which are bad, right? If module A depends on module C, and module C depends on module A, I have trouble building any one of them, because to build U involves building the other side, and then building the other side involves building U. And what happens if you both have changes? All right, that's going to be a problem. So we want to basically remove those cycles from our modules. But the value of layers is not just in that dependency, it's in the abstraction that they provide. Essentially, layers help us partition the system. We can take all our UI components and put them in a layer, and that is where we reason about UI. Okay? And I can swap that layer out for something else. Right? My MVC, my web API layer could be replaced with a console layer, so I can actually command and interface everything, because I've realized that the command and interface is best. That's really what we should be forcing our customers to do again. none of this JavaScript and HTML nonsense. They were better off when they just typed two little codes into the console, right? Or effectively, I can actually have it so it's basically one's talking to a web API, one's talking to my MVC layer, the different presentation layers that I want, okay? So I can swap out basically my infrastructure layer, right? I can decide essentially to have an in-memory database for testing. I can decide then to use a real database, obviously, essentially for actual production code, or maybe I don't. Maybe I decide in-memory database is good enough. And in the infrastructure layer, I may have, for example, third-party services that I'm calling. Let's say I'm calling payment systems, or I may be calling lookups for zip codes. And it's quite possible there are commercial providers who I have a falling out with because their service quality is rubbish, and I don't want to replace them with somebody else. By putting it in a layer down below and partitioning it off, I only have to replace that portion of the software. The domain is not impacted by me wanting to swap out the payment provider. Okay? So layering is a very useful partitioning of the system because it helps us to understand the system more easily. We can reason about what's happening in one layer without having to worry about what's happening in the other layers. And we can swap out pieces that we basically have decided that we want to change. So it supports change. And so we get some cohesion and reduced coupling by using layering. Sorry about that. Okay. One thing to note on this basically is the quite common approach here that says, actually, I'm going to split my domain into two kind of little sub-layers. I'm going to partition my domain layer further. I'm going to start thinking about that as having a service layer and an entity layer. Right? And the service layer is going to contain my application logic, and we'll talk more about what that is during this conversation together. And my entity layer is essentially going to retain basically my state and behavior around that state. Okay. So we can distinguish two types of business logic. Domain logic has something to do purely with the domain, right? It's basically saying, this is basically how I calculate your insurance premium depending upon the variables that you have given me. Whether you smoke, whether you're single, whether you have kids, whether you drive a fast car, whether you're a journalist. Apparently that's a big no-no. And that information tends to be basically what we consider logic belonging to the actual objects in the domain. Okay. An application logic, which is really to do with coordinating those pieces. In order to fulfill some request, I may actually need to talk to 2 or 3 objects. I might want to create a transaction to make sure that I have transactional integrity in the system. I might want to raise events to downstream systems to let them know that something happened. And this is not a responsibility of the domain, but it is a responsibility we need to fulfill if we are to basically provide the services that someone is expecting from our application. So the service layer provides application logic, right? So we talk about that split between the service layer and the entity layer. The service layer is providing the application logic, right? The coordination and control logic for our domain, the workflow for it. One of those key responsibilities quite often is simply to load the domain model, right? Your domain model essentially doesn't exist until you load it from the database. You can think of the entities, essentially a system, as kind of like a rules engine, right? The way rules engines work is you declare a whole series of facts and rules, and then essentially what you have to do is to populate those facts and rules with data, and then exercise the rules and say what happens. And really, you're doing the same thing. Your application logic layer is saying, right, I'm going to load these objects into the domain model, populate the domain with these facts, and then exercise the domain model. Load this customer. Look at their details. Now calculate their insurance premium. You don't always want to do that, right? So there's a bit of a caveat here. Sometimes, actually, your domain is very anemic, and you should just simply accept that. People talk about anemic domain model as though it's some bad anti-pattern that essentially you must never have. You shouldn't have an anemic domain model if you do have a rich domain, but sometimes, actually, your domain consists of just storing stuff, right? And that's fine. If you're writing a customer contact database, probably there's not a lot of actual detail, and you may be okay with a data structure and an application logic to control it. Don't panic if that happens to you. That's absolutely fine. Okay. And it's where we can put things like transaction control, security. There's orthogonal aspects of our application. When we service a request, there are many things we think of as orthogonal, transaction control, availability, retry logic, all those kind of things. And we can put those in our application logic. Okay. Two basic implementation variations. The service layer says, basically, I have a very thin facade. So I have a class or a procedure that essentially says, I just really directly call entity-level objects that do all the work. I'm not doing very much at all. And there's really no business logic crept into my, basically, upper layer. Okay. And the operation script approach says, actually, I have some more responsibilities here. Okay. I'm actually going to basically have some kind of business logic because this business operation is fulfilled by a number of entities which we care about cooperating. So actually, it's okay, there is actually some business logic here. And there are two variations on basically the same idea. Okay. Classically, what we get, most of you have probably seen this pattern if you've looked at any historic .NET code, is we get a class, it ends in service, it's called something like orders service, it has a lot of methods on it, and those methods represent operations on orders. We collect them all together and put them in one big class. Quite often it's static. We don't create any instances of it. And that pattern has been around in things like .NET and Java for quite some time. Okay. We tend to call it something like order service. All right. So maybe such a pause, isn't there, when I switch? To you, you're probably going, okay, it's a pause. To me, it's like it's like eternity. Okay. So what I can do is I can say, well, maybe we could rewrite this controller. So we're going to use this notion of a service layer. And I'm just calling it Facade here. A Facade is a name really for a class that acts essentially as a coarse-grained interface to the more granular classes below it. And so that's a typical service layer pattern. So now I'm just saying, oh, I'll call my Facade and get all of my tasks. Call my Facade and get that one task, right? And you can see once again to things like post, that's starting to pay off. Because that common notion I had of getting one task is now one bit of code that essentially I can repeat. Okay? And operations like add, regreet, these things are much simpler now. In my controller, I get a little bit, I got some more clarity about what I'm doing in response to an HTTP request. I'll build this one and show you it still works. But I won't do it for every single variation because we'll run out of time, but I'll do that when I'm talking about it. When I go and look at this facade, what does it look like? Well, so what it turns out is I've mostly done is just taken that code that was in the controller and moved it down one layer and provided some kind of abstraction. Okay. And that may seem, well, that's not very much in. But I have removed some duplication and repetition, right? I've now got one getAsync method, so that may be a help to me. And so every time I basically want to fix problems to do with basically getting a single request or getting multiple requests, then actually I've only got one place to fix it. Or if I wanted to modify my strategy because it was unperformant, I've got one place to go and fix that. But in addition, because I've actually taken it out of the controller, I've actually improved a number of other things I could do. I could test now at this layer. Right? I can write my test directly against my Facade, which means even though I'm testing the important logic, I've removed the need to instantiate that troublesome controller. So my tests are no longer dependent on that framework. My tests are now depending on my code. And that's always good, because it means that essentially my tests are continuing to exercise the work that I'm doing, not everybody else's. Okay. This is still a bit of a strange one, and we'll come back to that later, but we've managed to push this code, which basically pushes them into the console out as well, and that's actually given us a bit of cleanness and clarity. Okay. So that's kind of the typical first step that people will use when they're building stuff. Let me just run that through, and I can show you it still works. I say that, I mean, it'll probably just fail. I mean, we'll feel like all this time we spent watching it build hasn't really helped us. So we're just using Docker because it's simple to run up some infrastructure. If we come over here again and we find our test HTTP file, so occasionally we get asked the question, what is this? So this is basically a plugin for code called Restclient, which lets you essentially exercise curl statements and get feedback from them. So you can see basically I already had a couple of entries in the database, Alice and Mary from last time. I can add new entries into the database, right? And I can retrieve them. So functionally, I'm the same. And actually, these tests which work against the API continue to function normally, even though I've moved things down a layer, right? Okay. So it turns out there's an interesting idea in layered architecture called ports and adapters, and we referred to that earlier, right? And this is one of the ideas that Bob Martin began to look at when he decided to get towards this idea of clean architecture. What a ports and adapters architectural style, basically, this is a variation of the layered architecture which has 3 key layers. Okay. It has the application layer, which is essentially where the business logic lives, right? And you can think of that essentially in the previous as being roughly equivalent to our domain. That's where essentially our business logic is going to live. And it's got the adapter layer, which represents all the things that essentially are talking to something outside the system. So all of the I/O is an easy way of thinking about it, right? So the adapter layer is basically a layer that says, well, here is how we talk to the user via an interface, right? Here is where my MVC code lives. Here is where my Windows Forms code lives. Here is where my WPF code lives. Here is where my console lives. But in addition to that, it also includes, which we tend to think of basically as primary adapters, right? Because they talk to a primary actor, which is basically a user, usually interacting with the system. It also actually, the adapter layer includes my database, my third-party service that I call to look up postal zip codes or to look up essentially the weather today, right? So it has what we call secondary adapters, or secondary actors, which I talk to secondary actors, which are things outside the system that I need to depend on for the service of. And in this model, interestingly enough, whereas basically when we looked at previous models, let me go back. We had this notion of a separation between the domain and the infrastructure. Here, we don't have that anymore. We have this one adapter layer. And we've got this funny notion which confuses everyone, a port. And a port is what lives between the adapter and the domain layer, right? And it's referred to by Alistair Coburn as a purposeful conversation. So it's a conversation that occurs between the adapter and the domain. So it's more than just simply the interfaces to of the entity types live in the application. There's something else going on. It's this notion of purposeful application. And he refers to it effectively as the API of our application. And by that word application, he means what's at the core, what's at the center. Okay. And the goal here is to utterly decouple our application from any technology concerns. So if you look at this diagram, which is a classic diagram of a hexagonal architecture, what you will see is in the center, I've tried to represent with those circles a whole load of entities. They're basically our domain classes that represent how we provide the functionality of our application. In the outer layers, where you see feeds, user-side notifications, database, these essentially is the adapter layer. That's how we talk to the outside world. So on the user side, for example, we have an adapter for HTTP for basically providing an API via HTTP. We have a GUI adapter, so we can provide an MVC layer, so we can actually see stuff, right? Over here on the Facade database side, basically we have a database adapter. I can talk to a database. I can get information in or out, right? I've got notifications layer. So maybe I want to raise notifications via a message queue, so I'm going to use AMQP to basically raise messages. Or I've got WebSockets, or I'm sending emails, right? So this adapter layer is how I talk to those external concerns. A database is a separate process. My message queue is a separate process. My email is an SMTP server. My WebSockets will essentially are HTTP over the wire. I've got HTTP. I've got going to basically a user's browser on the user side, right? So the adapters manage their interaction with the outside world. And the port is essentially what lives in between the adapter and the application. So that's the adapter, that's the application, and that's the port. So when Coben says, effectively, the port is the purposeful conversation, effectively, between the outside world and the application, he's referring to that application layer there. Okay. One of the interesting properties of this model is that all dependencies are inwards. Okay? So the adapter layer is allowed to depend on the port, and the port is allowed to depend on the application, but the application is not allowed to depend upwards. So my application cannot call my database directly. So if we look at our layering model, we can see that essentially the adapter layer has both our infrastructure and our UI, and our domain or application layer has basically has our port and our application inside it in our domain layer. So the question might be, well, hang on a minute. If I need to talk to the database to get my data effectively in my to hydrate my model, how do I do that? Okay, from my domain model, and the answer is you have to use dependency inversion. So within my port, if I want to basically talk to and adapt to some piece of infrastructure or UI, so if I'm talking to the database, I define an interface, and that's basically something like my repository pattern, my iRepository, or my DAO pattern, my iDAO, right? Or my gateway for a messaging system. It's my iMessaging gateway. Okay. And that says at the port level, what I want to do is understand that I'm talking to the outside world, but I can't depend on anything concrete above me. So what I must do essentially is say, you have to basically depend on the interface, and then there's a concrete implementation of the interface provided when I spin the application up. So what happens in my main, at the beginning of my application, which is what's called the composition root, the place essentially where I hook everything together, then essentially I register an implementation of that interface with a container, which I can later then essentially use an IOC container or poor man's DI to essentially inject into the application. Okay? And by doing that, I preserve the cleanliness of my application. Okay. Let's talk about domains a little bit. We'll just take another run at the same idea for some clarity, right? So back in about 1992, I think, Ivor Jacobson wrote a book called Object-Oriented Software Engineering. Anyone read it? Wow, no, almost nobody. I see a few of your hands, but yeah. So this used to be like one of the texts for OO, right? If you were an OO programmer back in the 90s, this was kind of the text that you read. And what this text is most famous for probably is introducing the idea of use cases. Who's heard of use cases? Yay! Okay. Nowadays, to be honest with you, you can think of a user story as just a very lightweight use case, and that's essentially would be Alistair Coben's definition of a user story. It says it's a lightweight, informal use case. It does what a use case does, but essentially it doesn't have a very formal syntax. This is a more formal representation I pulled off the internet somewhere of someone doing a use case. Those circles essentially represent use cases, and someone's gone to look at what a business process is in a restaurant and said, what are the key use cases that we have to do? So let's say I wanted to basically, automate and give the server a handheld so they could essentially do all the interaction with the customer on a handheld. These would be the kind of use cases I'd start to look at. Okay. And a use case essentially says, what are the steps that I have to complete inside your application in order to provide some kind of useful functionality to the user? You can think of it as kind of a scenario, if you like, right? In order to essentially order food, the following things will have to happen. I have to basically send a ticket back to the system that basically has a list of food orders, etc. And the second thing, though, that is in that book that Jakobson came up with is a thing called Boundary Controller Entity, or BCE. Who's heard of BCE? A couple of people, right? That's actually quite unusual. So BCE was quite a popular model at that period of time, and essentially it's a model of how you slice up the software. Okay. So a boundary, that symbol is its UML symbol. So this is part of the UML standard. The boundary is the object, basically, that interfaces with system actors, user interfaces, gateways, and proxies, right? So essentially the boundary is an object at the outside of your system. And it says the actor, which essentially is a human being pressing buttons on your system or something that your system talks to, right? The interface with that is handled by a boundary object. Sound a bit familiar? Okay. Here's a diagram from Jakobson's book showing essentially actors, right? So I've basically got, looking at my customer panel, someone's got a receipt. I've got basically an operator who's looking at an operator panel or alarm devices. Okay. So this boundary object is how I interact with the system. And there are entities in your system. And the entities are the objects that store system data. And they also contain the business rules about that data. If we think about OO, which is really where this model comes from, we really want to have, although databases have kind of killed that model for us, implementation hiding, okay? And so implementation hiding is the idea that we're basically hiding our state. So the rules affecting that state have to live in the entity. And then finally, controller objects. Some people have renamed interactors to avoid confusion with things like controllers in the MVC pan, which mediate with the boundary between boundaries and entities. So they orchestrate the execution of commands coming from basically the boundary. Okay. And if a use case is a description of the way the system is being used, then a controller or interactor is the implementation of that use case. So our use cases live in this controller or interactor layer. And this is a typical diagram. I have an actor. He basically interacts with the boundary, some sort of UI. The UI in turn calls some kind of control objects, essentially to do some work, which essentially are the use cases, and should be named after the use case, something like order food or whatever, etc., which in turn orchestrate the entities. There are some rules. Actors can talk to boundaries. Boundaries can talk to controllers. Controllers can talk to controllers. Controllers talk to entities. But actors should never talk to controllers directly or to entities directly. And boundaries should not talk basically to entities or to other boundaries. That one you may have to relax, I suspect. And entities should not talk to entities. The idea originally was that essentially a boundary and an entity are a noun, and nouns can't talk to nouns. Nouns can only talk to verbs, and the controller is a verb. All right? But we can see this model has some parallels to the models we've been building up so far, right? We have this idea essentially of a boundary object, a control object, essentially. And they really are very much close to the adapter and the port and the application model. Okay. And indeed, Coben says a port is the use case boundary. Right? This is where we define our steps. So we can relook at this hexagonal architecture and say, well, that's basically our boundary objects. They're our entity objects. And in between are our control objects. So this problematic thing, the port, people get concerned about when building these architectures is really just essentially a control object, right? And there's a correlation between the use case boundary and the test boundary. So one of the advantages of a hexagonal architecture is we can begin to write our tests cleanly against this control boundary because those are the use cases in the system we want to test. And so you write your unit tests against that control layer, not against the boundary layer. And if you need to, then essentially you can write some integration tests to confirm you've hooked up your boundary layer correctly. But otherwise, you rely on system tests to prove that everything works end to end. Because as I just proved, when I switch between my different layers, then essentially that still works. My test still worked, even though I began to move stuff down the layering. Okay. So this is Bob's model of the clean architecture. And essentially it's derived from all those other earlier architectures, right? So you can think of the blue layer as basically your boundary, your adapter layer. The controller green layer is your ports layer. Well, the blue layer is effectively the outside world. The green layer is your adapters. So the blue could be frameworks like MVC for you. The green layer is your adapters, your controllers, the things that plug into the outer layer usually, or your repositories, your gateways to your messaging system. The pinky orange layer, the salmon layer, is essentially the use cases. That's your ports layer. That's where effectively the use cases of the system are exposed, and there you have your entities. Right? So this is how kind of it looks. You essentially have a boundary layer which talks to some interactors, which talks to the entities. Okay? And you may have a request and a response model, which essentially are when the boundary comes in, it delivers a request. So your HTTP request comes in, we take all the things in the header, we take all the body, and we give it over to the interactor and say, deal with this for me. It goes and calls the entities and deals with the request, and it generates basically a response model. What's the result of that happening? The response model then gets pushed out by the adapter and goes back to the user. Okay. If you have an MVC layer, then essentially it's part of that controller, right? So your controller is an implementation of the presenter, and essentially your response model is a view model that you are then putting out onto the view. Quite often the view is hidden from you in something like Web API, right? The view is, I just return my object, and it puts it out as JSON for me. And my entity gateway is essentially how my interactor talks to the adapter layer. It's that interface that we looked at earlier for basically dependency injection that says, I'm going to be basically how you talk to the database. And the implementation of it is something like a repository pattern or a DAO. Okay. So we'll speed through this bit quite fast. What I may do actually is just show you some code here, because of time. Right. So, given I start with this facade, then what can I do? Well, the first thing I might want to do with my facade is essentially say, well, when I look at my facade, there's a slight problem with it. And the problem is that the facade has too many concerns together. Okay? And so, because it has all those same concerns in my one facade, it's subject to too many forces of change. So I could break my facade up and have a whole set of facades instead. Right? And add a greeting service that just handles the proportion of the work that does add a greeting. A greetings all service that gets me all the greetings back. A greetings by ID service that gets me all those individual greetings. Right? So I take that big service model and I break it up. I say, actually, that's too much. I don't want to do that. Because all the forces of, I don't have separated interfaces for different customers and different clients. And it's hard to reuse. I have to reuse the whole facade, even if I only want one operation. But it turns out that model is really just commands. So the command pattern essentially says, I want to encapsulate the idea of calling the domain part of some kind of transactional boundary. And there's a strong alignment then between this idea of a command model and a use case. So I can turn those individual facade items into commands. So I'm just implementing an interface, IAM command, which is basically a standard interface, essentially, idea. Whoops, I'm not going to navigate to that there. Hang on, it's somewhere around. I will find it a bit later. So we're saying I can execute, right? And here I'm basically just doing the add, or I'm going to delete something. Okay. When I get to my controller, now I've got this nice idea of a command. I'm going to add a greeting, right? That's some kind of use case that I'm implementing here, right? I'm going to add my greeting. And my queries are similarly really just a variation of the same idea. I'm going to encapsulate the idea of doing this query for you. Where's my query? There you go. And so there I'm just going to execute that same code I had at the beginning as a query object. And these are my interactors. These are my ports, right? Representation of my use cases in the system. Okay. So what I'm doing here, for example, is I'm saying, when I get in the request model, create an interactor, the add greeting command, pass in the data from that request model, execute it, in other words, exercise the underlying entities, my greeting model. And then essentially, I'm going to raise an event out as well. We'll come back to that a bit later. And then essentially call a query object to build my response model, right? So I'm basically using interactors, which represent use cases, to handle the request and response model by exercising the entities. And the advantage of basically using some kind of command model is what I can actually do is use a framework, and this is using Brighter, but Mediator, etc., have similar ideas. And I can say I'm going to separate creating the command from executing it. Why might I do that? Well, if we go and look at add command, handler, rather, the receiver for that aggregating command, okay? We can see I have some attributes on there. And those attributes are handling orthogonal items, such as retry logic. Try and talk to the database if it fails. Just retry. Maybe it's a temporary error. Maybe it's a deadlock. You are trying to basically, it fails a lot, the database seems to be down, break the circuit, don't make calls on here anymore, give the user too many requests and get them to slow down. Okay? I want to log this. Okay? So that port layer, that interactor layer, is also a very useful layer for us to intercept and provide not just basically workflow logic, but control logic for our application. And we can insert that into the pipeline without really having to have any awareness of it when we look at the application logic. It's cleanly separated, so I can read my application logic, I can understand what's going on, but I'm able to add that on top. And my controller looks fairly clean, right? I'm creating my interactor, the aggregating command, essentially. Well, I'm creating the parameters for my interactor. I'm exercising my interactor indirectly through this dispatcher so that I can essentially have a pipeline of operations that it calls until I get to the entity model, right? So Brighter does this for you, Mediator does this for you. They're all basically variations of the same thing. Okay. So let's go through these reasonably fast. So what I was doing there essentially was saying, well, I had some service facade. I was worried essentially that I had a problem with effectively too many concerns grouped together. So I broke it up into a series of separate interfaces of my service, representing individual parts. I then essentially said, well, effectively, they can all be individual services, individual interactors, rather than one big interactor that does everything. I said, well, okay, those individual interactors that are broken up are just a command pattern, and the command pattern is very useful to me because the command pattern semantically is a transaction, it is a use case, and therefore it maps really nicely to this idea within the clean architecture of an interactor, right? Of this controller from the BCE model, of the port from a hexagonal architecture model. Okay. And it simply separates the caller from the entity model. So that's its job, is to separate basically the caller from the entity model. It's exactly what a controller does. It separates the boundary from the entity model. Okay? Standard interface for commands. And so I can see essentially my interactor model is effectively my command interface. Okay. Query objects, which are essentially just effectively this idea of an assembler that goes away, operates over my domain, and produces basically some kind of data transfer object, a view model. So I can create those as well. The idea basically of saying, to build my response model, what I want to do is have some kind of object that's an interactor that reads my domain and generates basically an output response. And of course, I don't want to get into detail on this slide, but that leads to the idea of Cqrs, this separation between the query side objects and the command side objects. Okay? This talk is not about Cqrs, so that's a detailed slide, I understand that, but the goal is really just to hint to you that we go down that route. And then we also looked at a command dispatcher, which is this idea effectively that I can separate the parameters of the command from the execution body so that I can insert operations between essentially the point I call on the boundary and the point that effectively I reach the entity. So essentially I can chain controllers together to separate the responsibilities of those controllers. So that some of my controllers do logging, some of my controllers do retry logic, some of my controllers do transactional control, some of them do authorization control, and when the ones at the end just do workflow. So I can separate all those responsibilities so that they only change because I'm changing that type of thing. I'm going to change how I do logging. I want to replace the logging framework I'm using. I'm going to change how I do retry logic. I'm not going to use poly. I'm going to implement something myself. Okay? That's the demo I just showed you. All right. So I think we are about on time. So I doubt I've got time for any questions. There's a lot to take in. The book to go and read is Bob Martin's book, which I showed you at the beginning, Clean Architecture, and also his blog post. You can go and look for hexagonal architecture online. There's a good discussion basically on Alistair Coburn's site of hexagonal architectures. And BCE is hard to define information about nowadays because it's a kind of like use cases and everything else is older. But there are various sources on the web talking about how BCE works. And there's some blog posts relating to Bob Martin's Clean Architecture where people actually talk a little bit in depth about how BCE model used to work. People picked it up from, but the BCE model is very mainly useful because people like Coburn, at the time he was writing hexagonal architecture, knew all about BCE, and it's kind of implied you understand use cases in BCE. People don't talk about that now, so ports become very confusing. All right, if you have questions, because we're out of time, I suggest you come down the front and I'll take them in the break. Please remember the tradition of putting green tickets in the box. It's a local tradition, which you should all honor as you leave. And thank you very much.